Something is wrong with dark energy. Imagine you're floating in perfect darkness, 10 billion light-years from anything familiar, watching galaxies drift apart like ash caught in a wind that never stops blowing. This is supposed to be the calm part of the universe's story, but astronomers just found something buried in the data, something that shouldn't be there, and it means the force pushing our universe apart might be changing its mind. From here, everything looks peaceful. Galaxies spiral slowly, stars flicker like distant candlelight, and space itself seems to breathe in silence. But something is wrong. For over 2 decades, scientists believed the universe's expansion was driven by a constant, a fixed, unchanging pressure called dark energy, quietly stretching space at the same rate forever. It was the one thing in cosmology you could count on. Steady, predictable, safe. That safety just ended. The Dark Energy Spectroscopic Instrument, DESI, spent years mapping the positions of tens of millions of galaxies and quasars, building the largest three-dimensional map of the universe ever created. It wasn't hunting for danger, it was just measuring distances. But when scientists lined up that map against the standard model of the cosmos, the numbers didn't match. Dark energy wasn't behaving like a constant at all. It looked like it was weakening, changing, evolving. But here's the problem. If dark energy can change, then everything we think we know about the fate of the universe is built on a foundation that was never solid to begin with. Let that sink in for a moment. Every prediction about how the universe ends, a slow, cold death, stars burning out one by one across trillions of years, assumed dark energy would stay exactly as it is today. Forever the same push, forever the same silence. DESI's data suggests that assumption might be wrong, and when the force controlling the destiny of everything might be shifting, you're not just looking at a scientific curiosity, you're staring into a blind spot the size of the universe. And it gets worse. This isn't one telescope catching a fluke. Independent datasets, supernova surveys, cosmic microwave background measurements, gravitational lensing studies are all being cross-checked against DESI's findings, and the signal keeps showing up. Not overwhelming, not proven, but persistent, stubborn. The kind of anomaly that refuses to disappear no matter how hard scientists try to explain it away. Some analyses put the statistical significance as high as 4 sigma, inching toward the threshold physicists use to call something a real discovery instead of noise. Now think about what that actually means. If dark energy truly is dynamical, rising and falling in strength over billions of years, then the smooth, eternal expansion we've imagined since Einstein is a lie of convenience. Something is out there acting on the largest structure imaginable, and it isn't holding still. It isn't obeying the rules we wrote for it. But that's not even the worst part. We don't know what dark energy actually is. Not really. It doesn't emit light. It doesn't interact with anything we can touch, measure directly, or hold in a lab. We only know it exists because of the effect it has. Space quietly, relentlessly pulling apart, faster than gravity can pull it back together. It makes up nearly 70% of everything in existence, and it is, in every meaningful sense, invisible. A force with that much power, hiding in plain sight, and we are only now discovering it might not even be consistent. Picture standing at the edge of a cliff in total fog. You can't see the ground below, but you know it's there because of the wind rushing past you. Now imagine someone tells you that wind, the only evidence you have, just changed direction for no reason anyone can explain. That's where cosmology stands right now. And this is where things change. Because if dark energy evolves, the two competing outcomes for the universe stop being distant, comfortable abstractions. One version has always been the big freeze. Galaxies drifting so far apart that the night sky, billions of years from now, would go completely black. Every other galaxy redshifted into invisibility. The universe left cold, dark, and alone. The other, more unsettling possibility involves dark energy strengthening instead of weakening far enough into the future to eventually tear apart galaxies, then solar systems, then atoms themselves, an ending physicists call the Big Rip. For years, scientists leaned toward the freeze, calm, slow, almost gentle. But if the strength of dark energy can genuinely shift over cosmic time, nobody can promise which of those endings, if either, is actually waiting for us. This isn't a distant abstraction happening out there, disconnected from you. The same expansion stretching space between galaxies also governs whether atoms can stay atoms, whether structure can exist at all. 1 billion years from now, 100 billion years from now. You are made of matter that only exists because the forces holding it together have, until now, been stronger than the force tearing space apart. If that balance is less fixed than we assumed, the story of everything ending gently was never guaranteed. It was a guess dressed up as a law. Here's what should really unsettle you. Humanity built its entire understanding of the universe's future on a number we now suspect was never truly constant. Physicists have a name for this kind of moment. When the model that explained everything suddenly can't explain the data anymore. They call it a crisis in cosmology. Not because the universe changed, but because we're only now realizing how little we understood about what it was doing all along. DESI will keep watching. The survey has already been extended, pushing observations further into the 2020s, expanding its map to more of the sky, gathering more galaxies, more distances, more evidence, trying to determine whether this is a genuine crack in the standard model of the cosmos or a statistical mirage that will fade with enough data. Right now, nobody knows. And in science, nobody knows about something this fundamental is one of the most dangerous phrases there is. Because the truth is this: the force deciding the ultimate fate of every galaxy, every star, every atom in existence, including the ones inside you, might not be fixed. It might be changing right now, silently, across a scale so vast that by the time we notice the difference, entire cosmic epochs will already be over. We built our sense of the universe's future on the assumption of a steady heartbeat. What if it's arrhythmic? What if it always was? The universe was never obligated to make sense to us. It doesn't owe us a stable ending, a predictable expansion, or a comfortable explanation. We are creatures who evolved to understand a small, temporary corner of existence. And even here, staring at the vastness that made us possible, we're discovering that the rules keep rewriting themselves the moment we think we've finally understood them.